Well, good afternoon, Texas Pelicans, and welcome to our channel. Today, I will be showing you the process for how to bring your roadway design information into your HEC-RAS deck editor data for modeling a culvert. Same process works pretty well for bridges. It's almost the same process, except in bridges, you need to worry about adding your piers and abutments and additional information to what we will be doing today. This is specifically for JMT Pelicans who have access to the worksheet we've developed to help make this process a little bit easier, but the concepts will work even if you don't have access to the spreadsheet. It's not that hard to make something on your own to go by. So I'm going to go ahead and share screen and we will get started. So what I have here is a basic HEC-RAS model. I have added as map layers some of our roadway design for IH20 that we're working on here. And we have a skewed culvert going across the roadway that we are going to model. One of the things that makes it easier is if you draw your cross sections when you have a crossing like this parallel with the roadway as much as possible. It makes the bridge deck editor a little bit easier. I like to do that around my crossings. Everywhere else, yes, try to be perpendicular to the contours, but when you have introduced a roadway crossing, it's just going to make things a little bit more straightforward. So we have one of the things I've done, our roadway design is in Open Roads Designer. So I will just show you the process. I took these cross sections out of our model, exported them to a shape file, and then brought them into the DGN file we have in Open Roads, applied the correct scale factor to get it lining up with everything we have in the design. So that's just a few little nuggets before getting started. And now we'll go ahead and show you one more thing in HEC-RAS. So I've added a structure here for where we're going to be putting this culvert. And the majority of this video, as I said, will be dedicated to showing how we get information from our design to pull into this roadway deck editor. I've gone ahead and added in our distance and width information. I try to do that to make it line up. Again, this is why it's good to have the cross section immediately upstream, somewhat parallel to the roadway, to allow the bridge shape to closely match what it actually is. So I just tried to enter those in to make those match. The culvert length will be the actual culvert length that we have based on our culvert layout, and the flow lines that we actually have. But with that, I'll go ahead and get started. So what we're going to be trying to do in the DGN, what we need is to get this elevation info that we have in our design and project it onto this upstream and downstream cross section. So one of the things that I get asked is what to use for your deck editor information, your overtopping profile. And you have some options. It's not going to really, unless your model is overtopping the roadway, it's not going to really affect the results. And so it's really, what do you want to see? So in my case, we've got a pretty typical scenario of a frontage road that is lower than the main lanes. And so I'll often want to see and double check our elevations against this low frontage road pavement profile. And then, so I'm going to enter that in. And then I like to, just in case it overtops, I think on the downstream profile on the deck editor, I think I will just use this PGL of the main lanes is my plan right now. So I'm going to pull up a spreadsheet that we have set up for this. So JMT users, this is available on the project-wise reference material standard design templates drainage directory. And what it does is basically converts what your roadway stationing is, or allows you to easily develop a relationship between your roadway stationing and your RAS cross-section stationing, which will feed right into your roadway deck editor, and then your elevation at the PGL versus what you want to be. So let's start with what we are going to do for the upstream deck. And so, as I said on this one, I'm going to use the frontage road profile for that. And I've already entered the elevations, but I just want to show you where some of this comes from. So what we need to enter, we need to give the spreadsheet a RAS 0 station. So HEC-RAS is thinking left to right. You're in a boat looking downstream. So for the upstream end, this is my upstream cross section, this 1348. This right here is the 0 point. So I've brought that into the DGN, and I need to use my handy dandy analyze point tool, click on the frontage road geometry and go to this point, and we've got that 0 station to be about 1072.77. So we've got that entered. I'm going to go ahead and fix that. It's a little bit off. So 1072.77. And then from there, and it's okay, from there, I've entered in roadway stations and the PGL elevation, which also is available from this tool. So if I go to say 1074 here, elevation is 454.82. 1000. Of course, I would pick one that I skipped. So let's do 1075. 455.33. So yeah, I've just entered these in about every 100 feet or so. Here's like I skipped one of them, but it shouldn't make a big difference. So, and the other thing we need to look at, so we've got the relationship to get the RAS station, and it's okay that some of them end up being negative. RAS can handle that as far as your station goes and drawing the roadway deck. That is fine. Now we need to know what elevation do we want. That's based on a cross section. So I've got a typical section here, and or one of the cross sections that I pulled up. And if I go to my measure tools, this right here is my PGL. So I want to go from here to about right there. That's the elevation I'm interested. It's about 16.6. I had 16.5 before. That's close enough. And the slope is 2%. You can measure that if you're in a cross-section view. You can check that by just drawing a line. That would be 20 over or 20 over and 0.2 down. And you can see it's close. I think I did something wrong there. 20 and 2. So maybe it's a little more than 2%. So maybe 2.1. Let's see. 0.21. Let me see if it's 2.5. 0.25. Okay. You know what? I know what I'm doing. It's 10. 10 and 0.2. Right on. 2%. So just had some fuzzy math there. So you put in that, and we've just set up the spreadsheet to do an adjustment of the PGL times that cross slope for that distance. And that's going to be our roadway deck elevation. For this downstream side, originally, so here we've got looking at the downstream end. Go back to the analyze points. Again, this one we mentioned we would do off the main lanes, center line profile. That's my downstream cross section. 627.35.66 is 0 to that. One thing I forgot to mention, let me mention that here, is the other key part of this in the spreadsheet is which way is this stationing going? It is increasing to the right, and downstream is going to the top. So in this case, it's going the same way as RAS is thinking. Sometimes your roadway is going to be going the opposite way. We've fed something into the equation, a little drop down here, and you just select opposite if it's going the opposite way, and it adjusts these equations for the stationing to do a little bit of algebra and figure out what it'll be when you're going backwards against the roadway stationing. So this one we had 627.36 for the 0, and that's by clicking on this and then going here. We've related that, and then we've gotten all the elevations, not all, but we've gotten a sample of elevations across that cross-section length to be able to project that onto that HEC-RAS cross-section for the roadway deck editor. So with that, this is in the roadway deck tab. I'm going to go ahead and take this data and copy out what is going to be in the roadway deck editor. And we have another spreadsheet, this example culvert. I've already copied it and made one for my specific culvert. So I'm going to take this and copy it here. This is where the roadway deck information goes. And then I'll take the elevations, the adjusted elevations, and put it right there. And then the same for the downstream side, except before I was thinking I would use the low edge of pavement for the main lanes. Now I'm thinking I will use just the center line. So I'm going to change this 61 here to 0. And I'm going to take these stations. Okay. And we set up this spreadsheet because HEC-RAS modeling and let's see. The one thing I've noticed here, I don't go back all the way. I would like to, so I'm going to get one more point. Or I could get one more point. Let's see, that's 6, 2734.94. I should probably go back. I'm going to go ahead and move forward. And but all you would do is add data to that. But for the sake of making this video not extremely long, I'm going to go ahead and move forward. So we've set up this spreadsheet though. To a lot of the numbers you're working in HEC-RAS, you are just doing a lot of basic geometry and math and measurements to get things into the model in the right location. So this just allows you to clean up the data, use some equations, and then feed it into RAS. So what I've done here is I've already copied in the upstream cross-section and the downstream cross-section for this bridge or this culvert. And those show up in these views here. And then the other thing is I've gone and measured the center line upstream, and that would be by measuring in HEC-RAS stationing units, which is again left to right, looking downstream. So starting at this end, measuring to approximately where that center line is, and then doing the same on the downstream end. So it helps you see that, hey, my culvert is lining up in the channel as expected. My roadway profile is doing what I expected to do. Helps you see that you haven't made a mistake. And it's a lot easier to check someone's spreadsheet of their model than the actual model. So I recommend using Excel extensively when developing HEC-RAS models. So we've done that. Trying to remember where I left off on this spreadsheet. So I've entered those in, and then so we've got two 8x6s, and I've put in some of the basic information in the structural notes. It's 424 linear feet, 438.84, 431.5. So now I can feed that into some of this information and then directly into the model. But so let's start here. The center line station, upstream and downstream. I measured those in CAD. Now I can make an equation since we have two barrels. So the culvert barrel 1 is going to be, it's a 8x6. So you got to allow for the space between the culverts and, half the distance of the width of the culvert. And that calculates that. And then I could go here, and that is feeding that. That's good. That's set up the way I like it. Then this flow line, I need to, this flow line I've entered in, and then I've made this an equation adding the height of the box. So I can kind of see how things are going. Now, on the downstream side, it's not in the channel, but there's a reason for that. That's because, if you're taking the cross section, this is the channel today, and we're actually extending it out a little bit. So it makes sense that it's back a little. So the cross section is cutting the channel here. The culvert's a little bit further over. What I may end up doing is adjusting the channel grading in the model at some point. But now that we've got that stuff, this is set up to be able to directly copy and paste into HEC-RAS, into the deck editor. So I'm going to go ahead and go here, go to my deck editor, and put that stuff in there. And now I can see it. See, that's that point where I need to go back a little further. But unless the water gets there, it's not going to make that much of a difference. And then I can look at my center lines that I've calculated and feed that stuff in as well. So I've got 578. I might even be able to copy. Let's see. Got on the culvert, we've got barrel 1. And I've already entered that it's two 8x6s. I've entered the flow lines. Barrel 2. Four 38.84, 431.5. Sorry, I'm entering the wrong things. This should be this station, the center line station of the barrels. So that is going to be upstream 578.5, downstream 589.5. And then for barrel downstream, it's going to be 469. 480.5. So now I should be able to look at the culvert and see that it sort of matches what we had in the spreadsheet. And it does seem to me. Effective areas need some adjustment, but overall it's looking pretty good. Um, I've already entered the length and stuff that I measured from there. So finally, I think I'm ready to run this one. I've entered the steady flows. One thing I haven't done yet, and in case you're not aware of this trick, I will show you for this video. We need to set some reach boundary conditions for the flows. Normally we do normal depth in most models. So I'm going to go ahead and hit that. And if you just keep your geometric data open, so I want to get the approximate slope of this channel downstream in, hold down control, click here. Actually, I'm going to click out of that, click here, hold down control, you get the measure tool. I'm going to click somewhere in the stream and just kind of make my way down a little ways. And I can say cut profile from terrain plot. And then again, hold down control, take some of the lower elevations, because you know that's more likely to be the channel, and then go maybe from there to there. And it'll give you your slope of your channel. So it's 0.007. So that's a good way to get that slope of normal depth boundary condition. I might do 2 measurements just to check that that is reasonable. I might come over here and do one. The longer the length, probably the more likely it is to be pretty accurate. The profile, maybe like that. 0.005, I'll use that one. That's good. And so I can go here, reach boundary conditions, normal depth, 0.054. Okay, my data. I think that's good. I think I'm okay to run it, and I'll see how it goes. Bridge 1 deck station is not increasing or blah blah blah. Channel mannings in and not set. So river station 1679. Okay, haven't set all my in. Looks like I just missed one. So that to be 0.07. Other error was saying not increasing order. Something. Checking here. 323, 423, 523. Looks like that point, however that. Looks like that last point got messed up. I'm just gonna delete that out. And I need to delete it out of HEC-RAS most importantly. There we go. It ran. Just for curiosity's sake, I'm gonna take a quick look at it, but I really showed you what I wanted to show on this video. Yeah, looks, so we had modeled this in another program, high 8. So just for comparison, we got a 50, or we got a 25-year, 446. And I think in high 8, we had 450.99 for a 50-year. So just a little bit lower. So, but within the ballpark, 451.73 for the 100-year. And this model still needs a little bit of refinement, but overall, I think it's doing pretty reasonably well. And we've been able to extract what is in our DGN of our roadway design, do that with whatever program you're using for your roadway design, and bring that into HEC-RAS. So that's all for today. Thanks for joining me. I hope you got something out of this video.